Alright, so welcome back to another chapter. And in this chapter, we'll be talking about the arc length and sector area. So in the next few videos, that's what we'll be doing. So without further ado, let's start with the syllabus first, as usual. So over here, these are the syllables for the NA level as well as for the express level. So if you notice that the express level seems to have a little shorter description, rest assured that whatever that is covered in the NA level is also going to be tested for the express level. So essentially, you guys will be learning about the same thing. The only difference is that you may notice for the NA level that these sentences are actually underlined. So what that means is that these underlined sections will only be tested in section B of paper 2, right? So that's the same drill as previous, where the underlined section will only be tested in section B of paper 2. Now, so let's see what is covered under the scope of the underlying section for a bit. So the use of radian and conversion of between radian and degrees. So that's one. If right now you feel you're not too sure what these sentences actually mean, it's okay. Just when we reach those section, I will mention to you guys again, especially for those students who are in the NA level. So that's that conversion between radian and degrees. Next is actually the problems involving arc length, sector area of a circle, and area of a segment, which kind of encompasses the questions that you'll be encountering in this whole arc length and sector area. So what that means is that those problems that are arc length, sector area, those will actually be appearing in your section B of your paper. So section B of your paper 2. So when we solve problems, do take note that those kind of problems will actually only be appearing in section B of paper 2. Alright, so let's go on and cover and start with the topic. So usually I like to start arc length and sector area with conversions first, right? So how to convert from degree to radian, and then later on radian to degree. So this is the section, the conversion of degree to radian and radian to degree is actually the section for any students that will only appear in your section B of paper 2. So as stated here, section B of paper 2. So this is one of the underlined scope. So let us start to talk about what is this. So degree and radian are actually just different units for angle. So much like money, right? You have your US dollar, you have your Sing dollar, you have your uh, ringgit, you have your British pound, so on and so forth. So these are all different units, right? The Sing dollar, the US dollar are all different units for money, right? So just like money, angle itself is has two different units, right? So one is the degree, and one is this thing called the radian. So if they are used to represent the same unit, which is angle, the same thing, right? That would mean that you should be able to convert from one form to another, right? And that's what we'll be doing here. So over here, I'll be teaching you how to convert from degree to radian, and then later on in the part below, radian to degree, right? So degree to radian first. How do we do this conversion? So the first thing that you need to know is that 360 degree, which is your angles at a point, right? One round is actually 2 pi. Okay, let me use a finer pen. is actually your 2 pi radian. All right. So that would mean that to find any or to convert any amount of degree to radian, you will need to first be able to find 1 degree, right? Because if you have 1 degree, you'll be able to find any amount of degrees that you want, right? And convert any degree to radian. So for 1 degree, it is dividing the 360 on the left side by 360, and then I divide the right side by 360 as well. So what does that do, right? When 360 divides by 360, which is itself, you will get 1. So any number divided by itself, you will get 1. So whatever you do to the left side to divide and get 1, you have to divide to the right side as well, right? So that the equation is still equal, right? So doing that, your 1 degree is actually going to be this 2 pi over 360. So let me rewrite 2 pi over 360 radian. All right, so that's how you get 1 degree. And after you get 1 degree, now you can convert any amount of degrees to radian. Right? Any angle that's in degree, you can convert it to radian. So over here, I'm going to show you with this 30 degree. So let's say 30 degree. How do I convert that to radian? I already know that 1 degree is 2 pi over 360. So if I want 30 degree, isn't it just like multiplication of 30, right? Take 1 times 30 and you get 30. So I essentially have multiplied 30 to the left side. So I'll multiply 30 to the right side as well. So that will translate to your 2 pi over 360 degree multiplied by 30 degree. Right? So we can put in the calculator to get the value of this. So let me do that now. And this is what I'll get. 0.523. Let's say I do 5 SF first, right? So I keep a bit more significant figures. And the reason for that is because usually after you do the conversion, the idea is that you will need to use it, right? So if it's the final answer, I will keep it as 3SF, so 0.524 radian. But if this is going to be something that I'll still continue to use, I can use the 5SF, 6SF. So use the one that is a bit more significant figure so that you preserve the accuracy of the answer. All right. So with that, we have done a very quick conversion from degree to radian. All right. So now, after converting from degree to radian, the other thing that you need to know is how to convert from radian to degree, so the opposite. Now, to convert from radian to degree, it's a very similar process. First, we got to know that 2 pi radian is actually 360 degree. So what is this 2 pi thing, in case you're wondering, right? So pi is 3.142, so on and so forth, right? We know that it's never ending. So 2 pi here is nothing more than just a fanciful way of saying 6 point, so taking 3.142 multiplied by 2, right? So you have 6.284, so on and so forth, right? So this is saying that 6.284 blah 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 radian is actually 360 degree. All right, but of course, so they over here they're using 2 pi because 2 pi is a better representation of all the values after 3.142, so on and so forth, right? So just putting 2 pi, you don't have to write so many, write out all the numbers. So over here, 2 pi actually just represents that amount, that 6 point something, right? Now, to find 1 radian, this is 1 radian, not 1 pi, right? So 1 radian is to, the way you can get 1 radian is to take your 360 degree divide by 2 pi radian. So take that 360 divide by the 6.2 something something radian, right? So 2 pi radian, once you are able to visualize that it's actually 6.2 something, right? You'll be able to treat it just like a number, and then over here, we are able to get 1 radian just by dividing it, right? Just by taking 360 dividing it. So very similar flow to the previous, and how we get 1 is the same, right? Divide by 2 pi on the left side, divide by 2 pi on the right side. So that's why I end up with this. Okay, so with that, we can go on and try to convert value, a radian, to degree. So let's say now I have 0.5236 radian, and I want to find out how much degree that is, right? So all I have to do is the same process, right? If I got 1 radian, I can find any amount of radian. So to find 0.5236, I'll multiply by 0.5236. And whatever that I multiply to the left, I'll multiply to the right as well, so that I get so that both the left side and the right side will be equal. So over here, 360 over 2 pi will multiply with 0.5236. Okay, so punching that into my calculator, I will do it now. So 360 over 2 pi multiplied by the 0.5236. And what you will realize is that if I were to do, let's say this is my final answer, right? If I were to do degree, because now I've converted from radian to degree, so this is gonna be 1 dp, and you'll notice that it's 30 degrees. So I purposely chose for us to convert this is to show us or to show you, right? If you convert 30 degrees and you get 0. This 524 or 5236 radian, when you convert from radian to degrees, you should get back the same thing, right? So when you convert 0.5236, you should get 30 degrees. Okay, because essentially they are representing the same thing. They're representing angles. So if they're representing the same angle, when you convert from radian to degree, degree to radian, you should get back the same values, right? So that's what I'm trying to show here, that radian and degree indeed are units, right? Different units that is used to represent angle. Okay, so if you're okay with this, go ahead and try these questions. Do the conversion on your own, see whether you can understand how to convert from degree to radian and radian to degree. And in the next video, we'll go through these conversions. All right, so I'll see you there. Thank you for watching to the end of the video, and I hope that you have learned something. If you did, don't forget to give this video a like and comment on one thing that you like about the video, right? Also, please help to share this video and subscribe to the channel because that will really help me a lot, and your support means the world to me. So if you don't like the video, no worries. Comment and let me know what you didn't like about it so that I can improve and I can change in the next few videos. Alright, so that's it. Thanks all, and I'll see you in the next video.